As we continue to talk about parallelograms, we are going to talk about trapezoids and kites. And, the question is, what are the properties of special quadrilaterals that are not parallelograms? And, we have discussed parallelograms to this point where we know that parallelograms have two pairs of parallel sides, and we know that our opposite angles of parallelograms are congruent. And what else do we know? That our opposite sides are congruent. So those are some of the basics for parallelograms, but now that we talk about quadrilaterals, which aren't parallelograms, and that gets us into the properties of trapezoids and kites. So if there is only one pair of opposite sides that are parallel, then that quadrilateral is going to be a trapezoid. So again, if there is only one pair of opposite sides that are parallel, then the parallel quadrilateral is a trapezoid. Now here we looking at that we have two bases. The bases here would be AD and BC because they are parallel. As you can see in our diagram, those are my parallel sides, and the legs would be AB and DC because these are the non-parallel sides. So you have AB and DC. Those are going to be my non-parallel sides. And all the altitudes would be the exact same. So drawn in here, we have this altitude, and they would be congruent or the same because the height is going to be the same because of my parallel bases. So all of the altitudes would be the exact same length because they are segments that are extending from parallel sides. So here, looking at the different types of parallelograms, and let me rephrase that, the different types of trapezoids. I'm stuck with parallelogram in my mind because we've done so many different topics on parallelograms, but now we're talking about non-parallelograms. So as the trapezoids, we talk about the isosceles trapezoid, and we can see here that in the isosceles trapezoid, we do have that parallel bases, but it turns out that the legs are going to be congruent. Just like when we had a isosceles triangle, our legs were congruent. The same thing happens for an isosceles trapezoid. Then we have a right trapezoid. I know that may surprise you that we have a right trapezoid, and guess what that entails? You got it. We have two right angles. So one of our legs is going to be a 90 degree, where it's going to form those. The two right angles are not the base angles, but we're going to get the leg from those two 90-degree angles. And then we have a scaling, and just scaling just means that none of my sides are going to be equal. They're all going to be a little bit different. So, however, we do still have that same parallel bases, which is one of the key properties of a trapezoid. So the bases of a trapezoid. So if a trapezoid is isosceles, then its base angles are going to be congruent. So if a trapezoid is isosceles, then our base angles are going to be congruent. And so as we see here, we do have a isosceles, and my base angles, since my sides are going to be congruent, my base angles are going to be congruent. So there we go. One set of base angles would be congruent, and the other set of base angles would be congruent. And let's see here. The orientation doesn't matter. Just because you have bases does not mean that your longer base has to be on the bottom. Your longer base can be on the top right here, as you can see. BC is actually appears to be longer than AD. And of course the same applies. Our legs in an isosceles trapezoid would be congruent. Our bases would be parallel, and then my base angles would also be congruent. So there you go. Your base angle B and C are congruent, and A and D are congruent. Oops. So therefore, if a trapezoid has one pair of congruent base angles, then it is going to be isosceles. And then angle measures of an isosceles trapezoid. If a trapezoid has one pair of congruent base angles, then it is going to be isosceles. So it is going to be isosceles. And let's see here, go ahead and label the missing angle measurements. Based on what we just learned about angle measurements of a trapezoid, we know that base angles are going to be congruent. So angle E and angle H should be the same value because it's an isosceles trapezoid and it is congruent. So let's see here, so that would be 47 degrees. Now the other two angles, you can think of this two different ways. One, you could say, well, according to parallel lines cut by a transversal, that angle F and angle E would add up to 180 degrees. So I could say that I would have 180 degrees minus 47 is going to give me 133 degrees. So F should be 133 degrees. That's one way to look at it. And of course, if the base angles are congruent, then I know that G is going to be 133 degrees. That is one way to calculate. Another way to calculate that would be to say, okay, I know that a quadrilateral, the internal angles of a quadrilateral add up to be 360 degrees. So I could say 360 degrees minus these two added together would be 94. That would leave 266 degrees. If you divide that by 2, that means each one of those remaining angles would be 133 degrees. So mathematically, you could have come up with it two different ways to determine that that is 133 degrees. Now, the diagonals of a trapezoid, so if a trapezoid is isosceles, or a trapezoid is isosceles, if and only if its diagonals are congruent. So we are going to find out that when we have a trapezoid, my diagonals will be congruent. So in this case, if, let's see here, if segment DF is congruent to segment EG, and if, let's see here, DG is going to be congruent to EF, then we know that the trapezoid is going to be isosceles. Let's see, what other information can we come up with? Let's look at this example and see. So it tells me in this example that EG is 3y plus 19. So EG here is 3y plus 19, and FH is going to be 11y minus 21. Find the value of y such that EFGH is an isosceles trapezoid. Well, if it's isosceles trapezoid, then we know that our diagonals are going to be congruent, which means the measurements they are equal to each other. So I could have 11y minus 21 is equal to 3y plus 19. And now I could combine like terms and solve. So I subtract 3y from both sides to combine like terms, and I have 8y minus 21 is equal to 19. I add 21 to both sides, and then I have 8y, that becomes 0, is equal to 40. divide both sides by 8, and y is equal to 5. Now, says find the value of y such that EFGH is an isosceles trapezoid. Well, it turns out that if y is equal to 5, then yes, we will have an isosceles trapezoid. And then we can even determine the diagonal length. They didn't ask us to do that, but we could say that EG is equal to 3y plus 19, which is equal to 3 times the value of y, which is 5 plus 19, or we would have 15 plus 19, which is 34. So there you go, my diagonals are 34 units. Didn't ask me that, but we should be able to calculate that. All right, so looking at the property of kites now, moving on, we know that a quadrilateral in which two pairs of the adjacent sides are congruent and the opposite sides are not congruent is called a kite. So look at our drawing here, look at our diagram. Two pairs of adjacent sides. So this side is adjacent to this side and it is congruent. This side is adjacent to this side and it is congruent. So there we go. That is an indicator that we have a kite, and opposite sides are not congruent. This is not congruent to that. So there we go. Now, so looking at this, we can see that WX is going to be congruent to WZ, and then XY is going to be congruent to YZ. There you go. So kites also have one set of, any ideas? They also have one set of blank angles that are formed by the non-congruent sides. Looking over here at our drawing, they are going to have one set of congruent angles. Opposite angles are going to be congruent. And these are formed in our two non-adjacent sides. So there you go. That's one of those, another one of those properties of a kite is those opposite angles formed by those non-adjacent sides are going to be congruent. So we have congruent angles. So we know that in this case, angle X is going to be congruent to angle Z. Okay, so continuing on and talking about the diagonals of that kite. In this case, the Kite diagonal theorem, the diagonals of a kite are perpendicular. The diagonals of a kite are perpendicular. So there you go. Those two diagonals form a perpendicular. Now, if we draw a diagonal AC, we create congruent triangles, ADC and ABC. So right here, doing some other things, this diagonal will split this kite in half, and then we end up with two congruent triangles. You have ADC, and then you have ABC. Those are going to be congruent, and we can see quickly that they are congruent because of side, side, side. And if we draw our second diagonal in, BD, so we draw a second diagonal in, BD, the theorem tells us that BD is blank to AC, and it is perpendicular, right? And so we see that perpendicular bisector, or perpendicular intersection. Now the diagonal that connects the congruent opposite angles is bisected by the diagonal connecting the non-congruent sides. What does that mean? That's telling us that this segment that we drew right here, this diagonal, is bisected by AC, which simply means that it has been cut in half. So we know that DE and BE are congruent. So let's see here. BD is equal to BE plus ED, and we know that BE is congruent to ED. So that's what they're telling us there as we look at that image. So looking at some of the examples that we have covered when it comes to this trapezoid and kite, let's see here. So in example number 2, find the measurement of angle ABC. Well, we have to remember when it comes to trapezoids, and this one happens to be isosceles, that my base angles are going to be congruent. So angle A and angle D are congruent base angles. So I know that angle D is equal to 115, and I know that angle D is also, another way of saying angle D would be angle ADC. So angle ADC right here is going to be 115 degrees. And angle, let's see here, continuing on, let's see here, angle ABC. Angle ABC is going to be, right here, is going to be 180 degrees minus 115, which is going to be 65 degrees. 65 degrees. And then we know that this is our base angle for the other base. So that one is, base angles are going to be congruent. So there you go. My base angle is going to be 65 degrees. This is going to be 115 degrees. Add those all together and they become 360 degrees. Let's see, looking at this next example, example number 3 here, it says find the value of x. Well, we have an expression here with x, and that is telling me that this angle is going to be 14x minus 15 degrees, and then this is going to be 139 degrees. Well, I know because of the properties that we have these two parallel lines, right? You can see them, and they're cut by a transversal. So if we think about it, same side interior lines would total up to be 180 degrees. So here, I'm going to go ahead and make angle, I know that angle S plus angle V is going to be equal to 180 degrees, and now I'm going to substitute. Angle S is 14x minus 15, and then angle V is going to be 139, and that is going to be equal to 180. So combine like terms, 139 minus 15 is going to be 124, and equals 180 degrees, and then I am going to go ahead and subtract 124 from both sides, and 14x is going to be equal to 56. Divide both sides by the coefficient, and x is going to be equal to 4. So if x equals 4, well, I just found out the value of x, so I don't need to do anything more than that. So there you go. We found the value of x by using the property of those two angles. And let's see here, we got 2 more examples dealing with kites. So as we look at example number 4, it says RS is equal to 10. So RS is equal to 10. And RU is equal to 9. RU is equal to 9. And it wants us to find QS. Well, QS is this segment right here. Or I'm sorry, that's US. QS is the entire segment. But I do know that if I look at it just for a triangle, for the sake of a triangle, this triangle right here, I can find out what a missing value is by using the Pythagorean Theorem, because it is a right triangle that kites intersect at a 90 degree. So I could use the Pythagorean Theorem to find out what the heck US equals. So I could say here that RU, or let's go A squared plus B squared is equal to C squared using my Pythagorean Theorem. And RU squared would be A plus US squared is equal to RS squared. So we have RU being one of my legs, so that is going to be 9 squared plus some unknown value squared is equal to 10 squared. So we have 81 plus x squared is equal to 10 squared. Not 10 squared, but 100. Subtract 81 from both sides. And let's see here, x squared is going to be equal to 19. Find the square root of both sides so we can simplify and find x. And x is going to be 4 something, I think. 1 second, let me get the calculator out. Let's see here, because 4 squared would be 16, 5 squared would be 25. 19 is closer to 16 than, see here, let's see here, the square root of 19 is equal to approximately 4.358, and I'm going to round to the nearest tenth and say 4.4. So if, again, if RS, sorry, US, US, not RS, US is equal to X, which is equal to 4.4. This is 4.4, then we know this is 4.4, so therefore SQ is going to be 8.8 units. So there we go, using some of those properties. And last but not least, what do we know here? Find the angle measurement of BAD. What do we know? Let's see here. In a kite, we know that our opposite angles of non-congruent sides are going to be congruent. So we know that angle B and angle D are the same, so I can say that this is 109. And I know that all 4 angles added up in a quadrilateral are going to be 360. So I know that if I add up angle A plus angle B plus angle C plus angle D, it's going to add up to 360 degrees. And angle A is going to be 5x plus 14. Angle B is 109. Angle C is 3x plus 8. And then angle D is 109. Still, all of that equals that. I can combine like terms. I can combine all my numbers, which will add up to be, let's see, this is going to be 117. Oh, I'm just going to cheat. 117 plus 109, and then plus 14. So this should, all our numbers should add up to 240. And then my variables, I have 3x and 5x, so that is going to be 8x. Subtract 240 from both sides, and I end up with 120 is equal to 8x. Divide both sides by x, and x is going to be equal to, I hope 15. That would work for us. So now if x is equal to 15, I need to plug 15 into angle BAD. Angle BAD is the same thing as angle A, which is going to be 5x plus 14, which is 5 times 15 plus 14 is going to be equal to 75 plus 14, or 89 degrees. So there you go. That is 89 degrees. So we're able to find the degree measurements based on what we understand about collaterals or quadrilaterals, what we understand about kites. So there are a couple of examples walked through to get us prepared and ready to do our lesson for the day, where we are dealing with kites, dealing with trapezoids. We're dealing with those quadrilaterals, those special quadrilaterals that are not parallelograms.